Okay, good day, grade 12. In this tutorial video, we'll be going through our last week's exercises. So, question number 1. The first term of a geometric sequence is 20. And you are told that t sub of 8 is equals to, that's supposed to be the value 5. That's 5 divided by negative 5 divided by 32. And then question number A. Show that r is equals to negative half. So in this case, we'll use the general standard equation of a geometric sequence, which is defined by t sub of n. It's a and then multiply by r raised to the power n minus 1. And then for our nth term at n is equals to 8, we know what our value is. So we have this on the left, and then we have our value n, and we are given the value a again. So our only unknown is just the ratio r, of which we are supposed to prove. So using this equation, we can do the substitution. We can say at the term number 8, we have minus 5 divided by 32 is equals to a, which is 20, and then we have r raised to the power 8 minus 1. So let us divide everything by 20, or we can multiply everything by 1 over 20 in order to eliminate this 20 on the right hand side. And then on our left we'll have negative 5 divided by 32 multiplied by 1 divided by 20. And then this side we'll have r raised to the power 7. And then let's compute this on the left and see. 1 minus 5 divided by 32. Okay, we're getting the value negative 1 divided by 1 to 8. And 128 is familiar. I think we can write that value as a base of 2, right? And then r raised to the power 7. Okay, let's see, 128, or rather 2 to the power 7. Okay, 2 to the power 7 is equals to 128. So that means we can rewrite this whole fraction as a power of 7. It doesn't matter what exponent we give the value 1, it's always going to be 1. So in other words, we can have 1 divided by 2, and it's still negative. All of that fraction raised to the power 7. This will forever be negative because our power is an odd number. And then on the left we have r raised to the power 7. And then notice that our exponents are the same, so we can equate our bases. In conclusion, we can say it is proved r is equals to a negative half. That's how you get the 3 marks. And then question number B. Calculate the sum of the first 8 terms. Give your answer correct to 2 decimal places. So this is a finite geometric sequence, so we can use the equation s sub of n, where n is 8, our first term, multiplied into r raised to the power n, where n is 8 again, and then all of that divided by r minus 1, and r is not equals to 1. So we have all the information to substitute into this equation. Yeah, just do the substitution and then find your final answer. Our first term is 20 into negative half raised to the power 7 minus 1 negative half minus 1. And then the final answer did I? I'm getting the value 13.43. Let me see. 20. Okay. Oh, I made a mistake. My n, it's 8, not 7. So the final answer is 13.28. 13.28. That's the sum of 8 terms of this geometric sequence. And then question number C. Given the series, and then you're given a geometric series, for what values of x will the series converge? So in order to determine the convergence of a geometric sequence, we need to know the ratio of that sequence. And to conclude that a sequence converges, our value of r should lie between positive 1 and negative 1. Only if the value of r is between negative 1 and 1, then we can say this geometric sequence does converge. However, in this case, given this sequence, that means our value of r will be in terms of x, and we are supposed to solve for that x to say if x is between these boundaries, that means this geometric series will converge. So we can use this given sequence and find our value of r. Our value of r, we can, okay, let me erase here. We can say our value of r, the standard way of finding the value of r, where you take two consecutive terms and find the ratio. So for this case, I'll only take the left hand side, but you can just prove. I'll take T4 and T3 to find my ratio. So T4, no, I don't have T4, so it's supposed to be okay, I'll just take this side, T3 and T2. T3, which is 2 into 3x minus 1 raised to the power 3, and then divided by T2, which is 2 into 3x minus 1 square. So these will cancel, cube, and then we'll cancel all of that. Then the ratio is just the value 3x minus 1. And even if you were to divide this by this, you should get 3x minus 1. So this means that's our ratio. Now let's substitute into that convergence condition. So we'll say 3x minus 1 is less than 1 and it's greater than negative 1. Now let us solve this inequality. Okay, let us transpose negative 1 to both the left and the right. So this side will have 1 minus 1, we'll have 0, it's greater than, no, it's 3x is greater than 0. And then on the other side we'll have 1 plus 1, we have 2. Then divide everything by 3, we'll still have x is greater than 0, however x is less than 2/3. So only if our value of x is between these two boundaries, then this geometric series will converge. This is our solution. Now question number D, it's supposed to be D here. Okay, find the sum, or rather calculate the sum of 2 into 3x minus 1 raised to the power k from the value k is equals to 1 to infinity if x is equals to half. So we are required to find the sum of this sequence. 4 marks. Okay, let us just substitute our k values 1, 2, 3, so that we just get the look of this sequence, and also we'll get our value of a, because by inspection this should be a geometric sequence, and since we're finding an infinite sum, that means we'll be using our geometric sum for an infinite series. so which is a divided by 1 minus r, and r is not equals to 1. So let's just substitute k and simplify. Let's see. For our first term, we'll say k is equals to 1. Then we'll have 3 times 1, which is 3 minus 1. No, I'm making a mistake. Here it's x. I'm substituting my k here. So we'll say 3 into multiply by half. We'll have 3 halves, right? 3 halves, then minus 1. All of that is raised to the power 1. So 3 halves minus 1, it's a half, and then half raised to power 1 is still a half. Then a half times 2, it's just going to be the value 1. And now for a second term, or rather k is equals to 2, it's going to be 2 here. The solution within the bracket is still the same. It's a positive half raised to the power 2 is going to be 1 divided by 4. Or rather, let me just write this. We'll have 1 divided by 4 multiplied by 2. And this is just 1 divided by 2. And then for our third term, we'll have a half raised to the power 3, which this will be 1 divided by 8, and then 2 times 1 divided by 8, it's 1 divided by 4, and then etc. So our ratio in this case should be just half divided by 1. Our ratio is just half. You can also prove that by dividing term number 4 and term number 3, you should get a half. So we can now come to the sum of a geometric sequence. Our first term, it's 1. So 1 divided by 1 minus, what's r? Positive half. So we'll have 1 divided by 1 minus half, that's just a half. And then this is equals to 2. So this is our geometric sum. We'll get the value 2. Question number 2. In the diagram, we are given B, C, and D lie on the circle with center O. So it's these points B, C, and D. They lie on that circle, and B lies on AC. Okay, there's a line segment AC, and we are told that A is equals to 50 degrees. So we have that, and AC is equals to CD. AC, it's a line, and CD. So these two lines are equal. We can just mark them. Determine the value of angle BOD. BOD. So it's the angle O1. BOD. We need to find this angle. So we have one of the rules in circle geometry that says the angle at center is twice the angle that it subtends at the circumference. So let us observe these two, or rather this chord BD from here to here. This chord BD subtends this angle at center, and again it subtends this angle at that circumference. So the relationship between these two angles, in other words, angle O1, which is angle BOD, is twice angle C. Angle at center is twice angle at the circumference. However, we don't know what this angle is, but we can find out. So remember that we were told that this line AC is equals to DC. So in other words, we have an isosceles triangle. And what property do we know about an isosceles triangles? Is that these two angles, they're equal. So if ever that is y and this is y, So the sum of angles in a triangle, we can just say 180 minus, minus 2y. We should get that angle there, the one that's missing, because the sum of angles in a triangle, they're equals to 180. So already we know 2, we can easily find the third. So in other words, we are saying there it's again 50 isosceles triangles. So that means this one should be 80. 50 plus 50 will have 100, then plus 80, it's 180. And then using that equation again, that means if ever our C is 80, that means O1 is equals to 2 times 80, which is 160. So this angle is 160 degrees. Okay, now the final question. Simplify the following expression to a single trigonometric term. Okay, we're just required to simplify in this case. So we can first begin by simplifying this one. We have a fraction here. So ideally we need to reduce this. We can convert our tan into, let's say, sine x divided by cos x. So obviously the cos x will cancel, and then we have sine divided by sine, which is just 1. So we now have 1 minus 2 sine, and then we have a compound angle here. However, our angle is negative. Ideally we'd like to make this positive, so we can just add 360 here. We can say negative 180 plus 360, we'll get positive 180. So in other words, we'll have 180 plus x. Okay, just added 360 here. So hence I now have a positive 180 plus x. And then it's still multiplied by, okay, we can go ahead and change this, because we have cos 90 plus. So our cos changes when it moves from 90 to that second quadrant. So we'll have a negative sine x there, right? So we'll have a negative sine x, and then we still need to reduce this, or rather convert this. So 180 plus x, our sine moving here, we'll have a negative sine x. We have 1 minus 2, then minus sine x multiplied by minus sine x. So our negatives will cancel, we just have a positive sine square x. So we now have 1 minus 2 sine square x, and simplify to a single trigonometric term. So this can be rewritten as cosine. Is it a double angle of cos? No. Is it? It's cosine 2x. Yeah, and that's it.